What does it mean when people say that machines learn? This is actually what we are going to understand in this video. Machines are trained and learn to execute tasks under a limited context and scope. They don't have general reasoning or true understanding. They cannot transfer knowledge from one domain to another without being retrained. So, like we saw in the previous video, as of today we are still in the era of the narrow artificial intelligence. So the concern that the machines will take over and go outside control is not yet applicable. I am Tiago Rodrigues, and this is the next step on our journey to make AI understandable. At its core, machine learning is about using data and experience to improve performance over time. It's not magic, it's statistics, patterns, and a lot of examples. For a machine to learn, we need to train what we call a model. And to train this model, there are different ways, but we always need to give data as input. And this data can be labeled or unlabeled. Then this data will be used by the existing model to predict an output. And then the output is compared against the expected value, and we have a returning feedback to the model. This returning feedback can be via optimization algorithm, like backpropagation. And this what we'll do is to adapt the weights in the model that will be used to calculate the prediction of the output. And this feedback repeats over and over again, this entire cycle, until we reach the expected performance of the model. So for a certain input data is providing an expected output. And so to train this model, we actually talk about machine learning. And there are three main types of machine learning. One is supervised learning, another one is unsupervised learning, and the third one is reinforcement learning. So we will see that the difference between supervised and unsupervised is mainly in the type of data that we give as input. One is labeled, the other one is not labeled data. And reinforcement learning is mainly about feedback to the provided prediction of the output. So on supervised learning, the input data is a combination of multiple items that is usually called structured data. Includes what we call labels. So let's say that we have this example of images with dogs. So apart from having the image, we have the label mentioning it's a good dog or it's not a dog. So in the real world, usually what we do is we will have a folder with the images that are dogs and another folder with images that are not dogs. And then we feed both folders to the model. And during the training, he knows already that all the images that are within the folder that is labeled as dog, the images are supposed to be dogs. The other one, it's images that don't correspond to dogs. And so when we feed that data into the model will start predicting the output. And like we saw on the previous slide, so this will reiterate internally, adapting the model weights and parameters until it gets the expected output. You can think about teaching kids on what is a dog, what is a cat. So supervised learning is all about giving an input A and pair it to an output B. Right? So like an equation, mathematical equation. And so if we are outside with our kids and we point to a dog and we say, this is a dog, and then we point to a cat and we say, this is a cat, we are already labeling that data. So we are showing the animal to the kid and we are telling him if it is a dog or if it is a cat. And this is a good example of supervised learning. And so the model in a supervised learning environment, we will pick up these different types of data. It will reiterate internally, comparing the provided estimation or the provided prediction as an output, and then it will learn based on the internal weights parameterization if an image represents a dog or not. Then we have unsupervised learning. And on unsupervised learning, we provide data as input that is non-labeled data or unstructured data. So we provide images, we provide texts, but we don't attach a label to it or a category to it. So the model will digest this data as input and it will try to understand internally what kind of relevant parameters are there on that data that will allow him to make predictions of the output. So in this case, it will understand that there are certain characteristics like eyes, ears, and legs on this image. So it will kind of adding it to a box. So then we provide another image, like image B. In this case, that we provide is image B, that is a dog. Again, it will reiterate the model, it will identify relevant parameters, so it also have eyes, it also have ears, but the nose is different. At the end, after the learning, it will understand that this image is similar but kind of different from the previous one. And again, and so forth. So it will continue image after image, trying to understand what are the similar parameters and the different parameters between all the images that are being provided. So again, if we are coming back to our kids example, let's say that we give our kids a box with animals. So we have a box with toys with different animals here. And then we just ask him to split these animals into groups. And let's say that then he will be able to put dogs in one area and cats in another area. But we are not telling him, okay, just put dogs or cats. No, we are just saying, okay, group them together based on characteristics. It will try to figure out what are the relevant characteristics that will make those animals similar or not similar. And it will try to group them together. Then, when we talk about reinforcement learning, let's think about a dog. For instance, when we have someone trying to train a dog, the input data can be the dog trainer saying the dog to sit. So then the dog, that is our model representation here, will make an action. And let's say that that action is actually to sit. So then there is the validation. So actually the action was the expected for the instruction of sit. So then we can reward the animal. And he will learn for this instruction of sit, the expected action is for me to sit. The same thing if the trainer says sit and the dog runs, right? So in that case, we are not giving a reward. By repeating these actions over and over again, the dog will understand what he should and what he should not do based on the instructions that is given. A similar analogy can be done for a kid riding a bicycle. So we are not telling all the instructions and all the detailed instructions for him to learn how to ride a bicycle. But if they fall, is a negative feedback. So they know that whatever actions they did were not the correct ones in order to learn how to ride a bicycle. On the other hand, if they are able to stay balanced, it's a positive feedback. So they will know that whatever actions they did were actually correct and were able to make them be balanced and ride a bicycle. Now, after this brief explanation about supervised, unsupervised, and reinforcement learning, just bringing to you 3 real examples of how we can apply artificial intelligence models to the real world use cases. So starting with email spam detection, this is a clear use case of a supervised learning model. In this case, if you remember a couple of years ago, all of us were told to mark a spam email as spam. And so it would be to our corporate IT departments, so they would know that the specific email was marked as spam and confirming it. So after all these years categorizing emails as spam, so now we have lots of data with examples of spam emails. So we can actually feed all those emails labeled as spam or even not spam to the model. So the model will optimize itself and adapt the internal parameters to be good at identifying an email as spam or not spam. So finding the patterns and the similarities between all the emails that were marked as spam. On the other hand, we have, for instance, customer segmentation in marketing. And this can be used into many ways. But if you are familiar with making purchases into Amazon or online shops, probably you came already across suggestions of products to you that other people did after buying the same exact equipment or the same exact product. And this is based also on artificial intelligence models, where they will be given with purchase history of the customers, but no labels at all. So the model will start to understand patterns and identify when a certain person or a lot of people will buy a certain product. Most likely they would also search or buy other related products, and they will provide that recommendation for you. So this is a very good example of unsupervised learning. So we are only providing the purchase history of different customers to the model. So then it will be able to understand, based on whatever products you have selected to buy, it will be able to recommend you other products that you might be looking at. And then regarding reinforcement learning, let's talk a bit about automotive. In this example, we are talking about optimizing the adaptive cruise control mechanism. This is actually optimization after the initial development of the system. So we should be able to optimize and maybe later deploy this update with a future software update. But the idea is how to optimize an existing algorithm. So in this case, we would have an environment that will simulate the traffic conditions into the model. And then we can treat the car software as an agent that will perform actions based on the traffic information. And then we can have a reward system for the comfort, the safety and efficiency. So if the actions of the agent are contributing for a smooth driving or keeping the expected distance from the car in front, or even reduce the acceleration and braking actions, maintaining the expected speed. So all of these conditions will contribute to give a feedback, a positive or negative feedback to the model in a kind of reward mechanism that will make the model be even better. So in this case, it's an optimization. The model already performs the expected actions, but can be optimized, can be better. And this is an example on how in automotive industry we can use reinforcement learning as a component of machine learning to optimize an already existing algorithm via artificial intelligence model training. So machines don't think. They find patterns in data and make predictions based on experience. In the next video, we will understand a bit better the difference between machine learning and deep learning. We'll also see why neural networks are such a big deal today. Thanks for watching and see you in the next one.